Yep, we're recording. All right, welcome to Statics. My name is Dr. Michelson. Again, as I said, I'm going to be your instructor this semester. What we're going to do today is just go through how the class is going to be operated. We're going to talk about the syllabus, talk about what we're going to talk about in here, the grade, all that good stuff. Just so you all are aware, a couple of announcements. So the way I do classes, I always start every day with a little announcement slide, just letting you know what's going on. So don't forget, I had it here on my slides, don't forget to sign your return to campus agreement, but everybody in here had already signed that, so you're good there. You all know the drill with the mask policy and all that, so I'm not going to belabor it. My office hours are Monday, Wednesday. I said Monday, Wednesday, Friday, but I'm pretty much around anyways. But Monday, Wednesday, 11 to 1, Tuesday, Thursday, 10 to noon. I'll talk about my office location, all that here in a bit, but I just wanted to have that on here. But again, like I said, what we're going to talk about today is just how the class is operated, the syllabus, and so on and so forth. But before I get into that, first thing I'll do is I'll tell you a little bit about myself. I'm going to break the rule of PowerPoint presentations. I'm going to show you my best slide first. So a little bit about me. So first off, most important stuff, that's my family over there on my right. On the right, that's my daughter, Stephanie. She just started preschool a little bit ago. She's in stage 3 of no, where stage 1 is hearing the word no and not liking it very much. Stage 2 is learning to say it back to us. But she's in stage 3. She enjoys to say it back to us. So I'm just kidding. She's going to hear this recording one day and go, Dad, why did you do that? And yeah, that's my wife, Becky, there at the bottom, when Stephanie was a little bit smaller. So a little bit more about me. I'm a faculty in the civil engineering department. I'm also the associate dean of the college. Some of you, if this is your first semester or whatnot, because I know we have some first semester students in here, might have interacted with me over the summer. But yeah, so I'm in the dean's suite. I'm on the 2nd floor of the new engineering building. If you ever had to deal with Dr. Wajudi before in his capacity as associate dean, he's become the chair of the computer science department, so now I've taken over as associate dean. And a little bit more about me. I graduated, yes, I went to that school up north. I graduated with my PhD from WVU in 2014. I'm a registered professional engineer in the state of West Virginia. And I've been in Marshall ever since. And like I said, I'm a civil engineer, and my real area of expertise is bridges. I'm a bridge engineer. So it definitely makes sense for me to be teaching this class when you learn a little bit more about it, because this class is all about keeping things in equilibrium. And I would hope that bridges sit still, because when they fall down, that's a bad day. But yeah, a lot of my work involves bridge engineering, and particularly trying to make bridges more efficient and more economical. A lot of my work here over the past couple of years has sort of been monopolized around a concept called press brake form tub girders. And basically the idea is that you take a standard mill of plate of steel directly from the mills. Structural plate comes in standard sizes, a lot like how plywood or lumber comes in standard sizes. And instead of cutting them out or welding an I-beam out of those plates, the idea was to bend them into a U-shaped tub and use those for the beams for the bridge. And the technology's gotten a lot of attention in the industry. We've built multiple bridges in various states. We actually built 2 bridges in West Virginia over the past couple of years. One of them in District 2 near East Lynn, and another one in District 4 near the northern part of the state. So it's been really exciting, amount of work. And I've done other research with the American Iron and Steel Institute and the West Virginia Division of Highways. If I'm a bridge engineer, if I wanted to get more specific, I'm specifically a steel bridge designer. Steel is my area of expertise. That's what I spend a lot of my time researching. I'll skip a lot of the other biography stuff because I kind of want to get into the point of the discussion for the day. But the one thing I'll mention before we get into the nitty-gritty about the class is, I know we got a lot of people in here. There's about 61 people in the class, but the biggest thing I want you to know is that I want you to feel like if you ever have any questions or whatnot, that you feel free to raise your hand and ask. The last thing I'm going to do is start barking at you, don't interrupt me during class. No, absolutely not. This is your time, this is your money, so I want you to get the most out of it. And we are going to be talking about some somewhat complex things in here. We're going to be talking about forces in 3 dimensions and how much they tend to rotate axes in 3 dimensions. I mean, this is actual stuff we're going to be talking about in here. So we are going to get kind of technical, and we're going to get kind of mathy in here. So if you ever have any questions, please, stop me and say, Dr. Mike, what the hell was that? I didn't understand that. Especially now, I mean, the first time I taught this class was last year during the pandemic, and so it was a very interesting challenge. In the end, I think the students came away with it with a good experience, but I want you to take advantage of the fact that we are here in person, okay? So please, take advantage of that. Okay, let's talk about the grade structure in the class. So, and I'll pull up the syllabus here in a bit because I have the syllabus posted on Blackboard. But everything that's in here that you see on these notes are also posted on Blackboard. I'll talk a little bit in a second about the technology tools and whatnot we're going to use in the class. But here's the deal with the attendance, the grade. The attendance is worth 10%. This is definitely a class where you need to be here. This is important stuff. This is the foundation of just about every base engineering discipline there is, whether it's civil engineering, mechanical engineering, biomedical engineering. This is important stuff. So I want you here. What's most important in terms of your grade is the homework. Okay, the homework and actually doing the work and getting it done. That is the most important thing in this class, bar none. So it's worth the most. There are 4 exams in the class, 3 during the semester, 1 comprehensive final. I usually don't do comprehensive finals in my classes, but there are a very few exceptions where I think it makes sense. And this is a class where it makes sense, and that'll become clear as the semester progresses, that the material does sort of build on itself a little bit. As for the textbook is the 12th edition of the Vector Mechanics for Engineers. The nice thing about this textbook is that it will serve you for both statics and dynamics. It's the same book. So I know it seems like a chunk of change, but you get to use it for 2 different classes. And this is a textbook that you will reference and use for your career. So it is an important get. Okay, let's talk about operating this class. And I got to tell you, again, I am definitely relishing the fact that there are people in this room that I can look at and talk to. I had a buddy of mine, he's a bridge engineer at HNTB, and he and I were chatting around October and whatnot last year, and he said, how are all these, how's classes going? Because this was in the middle of virtual learning. And I said, well, I'm getting used to standing in a room by myself, talking to myself, so I don't think that's a very good thing. And I know that you all probably got a little tired of it on your end too. But one of the things about the virtual learning that we did last year is that, what's the saying? It's like necessity is the fertile ground for innovation, right? And I mean, if there's any description of engineering, I think that's a pretty good one. But there were a lot of technology tools and software packages available to us that really did make things more efficient. And even though we're back face to face, some of these tools I still want to use, and I think that you will get some benefit from them throughout the semester. So let's talk a little bit about some of these. So first off, the primary tool that you need to be aware of is Blackboard. I'm sure that you all are probably familiar with it already in some of your other courses. And I'm sure you've probably had a spectrum of experiences with Blackboard. You've had some faculty never use it at all, and some faculty use it religiously. I'm probably in the latter half. I use it very rigorously in my classes. So I'm going to post all of the grades to Blackboard, and I do I think a pretty reasonable job of keeping them up to date. In terms of the materials for the class, all of the lecture notes, the homework assignments, the solutions to those homework assignments are all going to be posted on Blackboard and are going to be submitted via Blackboard. You're going to submit the homework via Blackboard. You're going to do the exams via Blackboard. So let me explain how the exams are going to work. We're actually going to do the exams here in person. There's more than enough room for us to spread out. But I think that in terms of ensuring that you get the adequate time to do the exams, we can all come in, set up your laptop on one desk, maybe scratch paper on another. There's 169 chairs in this room, so there's more than enough space to do it. And then I can turn the exam on at, technically class starts at 1 p.m., but I might turn it on at 12:58 or something. Then everybody's exam starts at the same time, and we'll let it go to maybe like 1:55 or something to give you a little bit more time. And you'll be able to sit here, work on the exam, and submit it all via Blackboard. And I did that during the pandemic last year, and I think it kind of makes sense this year, just given the fact that there's so many people in the room. Just the act of handing out 60 exams to everybody in the room, I think it's just going to eat up valuable time, and I'd rather you have the most time available to actually doing the exam. I think that I want to see you all do well in the exam. Another tool, which is free by the way, that I think that you should put on your smartphones if you don't already have it now, is Cam Scanner. So we're going to be doing a lot of homework assignments that involve doing calculations, drawing diagrams, and so you're going to do that on engineering paper, copier paper, and so on and so forth. And in order to turn that in, what you'll do is you'll submit a scanned PDF. Cam Scanner is an app that you can put on. It's on Apple and Android. It doesn't matter. It's an app that you can use that will basically take a picture of your homework and turn it into an 8.5 by 11 PDF, and then you can upload it. There's a little link here where I go through step by step, literally how to take a picture of your homework and turn it into a submission on Blackboard. I go through the whole process. And again, this lecture is on Blackboard. I'm going to pull Blackboard up here in a second, so you've got all of that. I actually walked that through step by step last year. You can also use a scanner, like there's scanners in Drinko and so on and so forth, but it's a really, really handy app. Okay. I did start a Microsoft team for the channel, for the course. I will probably not use it a lot, but there is one tool I will use in that team very religiously, and that's OneNote. I'll talk about that here in a second. But what I've used Teams for in the past, what I used it for in the pandemic days, was just to do quick periodic announcements. So how many of you were here last semester during the craziest ice storm this region has experienced in the past, 30 years? So I had students that were like, okay, what do we do with this homework? Is it turned in? Because things were going very quickly. And I just sent everybody a message on Teams that, hey, don't worry about staying warm and keep your power on. We'll turn the homework in when you come back, so don't worry about it. I lost power myself for a little over a day, so I definitely understand. It might serve as a backup for live lectures if we need, like we had some crazy weather or something. But again, primarily I plan on operating face-to-face. That's obviously the plan. There is one resource that I think is very valuable to you all, and that's OneNote. So if you go onto the team for this course, at the very top there'll be a tab that says Course Notebook or Class Notebook, okay? What I'm going to do when we do problems together, and let me actually pull this up. So this is the class notebook for the class, and I just have a particular, this is going to be one of our first examples that we do together. It's really simple and whatnot, but this will be sort of, how I, do examples in class, okay? I'm going to leave that, what I just wrote, I'm just going to leave that there, okay? This OneNote, what it does is it syncs to the class notebook in the class, and literally every single person in this room, 24 hours a day, 7 days a week, will have access to what I write on board. That's what this is going to be, is what's on board, and it will save for everybody to access. And so, virtual learning began. I think this is a really cool resource. I remember when I was in college, if I could have a snapshot of literally every stroke of chalk on the chalkboard that was ever done in a class, that would have been great. So if you missed something, don't worry, it's all here, it's easily accessible. I'll show you how to access it. I don't want to get too far into the details, we're not going to need it today. I'll show you how to access it on Wednesday, because we're going to start with some basic unit conversion stuff, but just so that you have access to that. Any questions so far? Again, don't hesitate if you got questions. Please. You all, the way I look at it, whether it's scholarships, loans, your parents, somebody's putting cash money for you to be in this room right now. So if you got questions, you ask them, okay? But don't hesitate at all. Everybody good? All right. Okay, let me go back to the presentation. Okay. Now, so one of the things that I did want to do is that even though I did learn, and we all learned some different ways of doing things, we are face-to-face. And so I did want to revert as much to my face-to-face operation mode as possible. One of the things that I used to do well before the pandemic happened is I would record all of my lectures and post them to a YouTube playlist. So everything that you're seeing on the screen right now, everything that I'm saying is being recorded. Normally I have like a lapel mic that I clip on, but of course, right before the semester started, my lapel mic decided to poop out on me. So I've got one on Amazon on its way, and in the meantime, I've just brought in my little podcast microphone that I used for recording lectures last year. But yeah, the idea is that I'll have this lapel mic on. I'll be able to walk around, ask people questions, and so on and so forth. I think that in the past, students have loved that resource. I'm going to continue to do that. Again, with attendance, so remember the grade for the course. There's attendance, the homework, and the exams. The attendance, you saw how we're going to do that. I'm going to come in, I'm going to pull up the QR code. We're all going to scan it, and then we're going to move on. If you miss the QR code, that's going to sort of be how I determine whether or not you're late. Just so you're aware, I'm not counting anybody late today. It's the first day. If I got you on the attendance roster, that's good, so don't worry about being late today. But I'll pull that up, and that's how we'll do the grading for the homework. Again, the attendance is not going to make or break your grade in the class, but you do need to come to class because this is definitely a class where you want to participate. Okay, let's talk about the homework. When we went virtual, I did something a little different. One of the things I did with the homework assignment is I used to do these like weekly homework assignments. We would have a homework assignment, it would be due in a week and something, maybe something like that. And because we were virtual, I said, we got to have a reason for everybody to log in. So instead of doing weekly homework assignments, I did homework assignments that were due after every lecture. So for example, we'd have a homework assignment Monday that's due Wednesday, one that's Wednesday due Friday. It wasn't more work, it was just the same amount of work spread out. And I'll tell you, I thought I was going to get raked over the coals on my course evaluations at the end of the semester. The exact opposite happened. The students loved it. They loved it because it's not as if the homework assignments are very long. I mean, some of these homework assignments you'll be able to complete in 5 or 10 minutes. They're not intended to be rigorous. I mean, some of them might be a little long, but I mean, we're talking a half hour to an hour for these homework assignments. But by doing them regularly, you're keeping up to date with the topics. We do a topic, we lecture a topic, we do a homework, and then we submit it and we move on to the next topic. It keeps us moving forward, it keeps us on pace, it keeps you engaged, and it's not that much work. It's the same amount of work, just spread out. In the end, the students love that, and so I still want to do that in here. So we don't have a homework assignment today, but we are going to have a homework assignment Wednesday that's due Friday. When you see that homework assignment, you will see what I mean. You will probably be able to finish it in about 5 minutes. It's really not that much work. Again, that isn't going to be the case for all the homework assignments, but as we do these assignments regularly, I think you'll start to see the benefit of that. The homework assignment, that's our first homework assignment, the one that I assign Wednesday and that's due Friday, I'm doing it a little differently. It's going to be like a form that you enter, because when you see the homework assignment, you'll understand it's really simple. You'll just be able to do the problem, enter the answer in, and that'll be it, because they're really simple. But for homeworks that we scan and submit, which will start to happen probably starting next week, I'm pretty easy to get along with in terms of the format, but I do have some requirements. I want you to use either quad paper, like engineering quad paper, or letter copier paper, and I say that because it makes for an easy to read scan. In terms of everything else on the format, make sure that the top of the page has your name, has the course number, has the homework number, and the pagination. So what I mean by the pagination, if it has 6 pages, say this is page 1 out of 6, this is page 2 out of 6, so on and so forth. I say that simply because if I download these to grade later, that it would just be nice to have that for reference. The other thing is I do want you to use a straight edge for your figures, because we're going to be drawing a lot of figures and a lot of diagrams in this class. There's a lot of physics and math that goes along with that, so there's going to be figures. I do want you to use a straight edge, and for any of you that say that you don't have a ruler, you have a straight edge. Everybody has a straight edge, right? I'm not asking for anything like Rembrandt. Just make sure that it's legible, make sure that it's neat, make sure that it's professional, and I'm good to go. The way that I do the grading is usually each homework assignment is worth like 10 points. If it's late, I take 20% off, and I will continue to take late homework assignment basically until I grade it. And once I grade it, then I can't take it because I post the solution right after. But one of the benefits of doing homeworks every day is that because there's so many of them, if you miss one, it's not the end of the world. So that doesn't mean miss homework assignments. It just means it's okay if you miss one every now and then, and it'll be all right. All right. Any questions on the homework assignments? Don't worry, you don't have one today. It's okay. Everybody good? All right. Exams. We don't have exams in college. We have celebrations of learning. So we're going to be celebrating 4 times this semester. 3 times are going to be during the semester, and then the 4th time is going to be during the university scheduled final exam slot. The 4th and final exam is comprehensive. The rest are not. Okay. So what I mean by that is, for exam 1, we will test on some material, and then exam 2, it's a new set of material. It's not the same stuff from exam 1. At least that's the way it's intended. Some of the material in this class does bleed over from exam to another, and that's unavoidable. To give you an example, the 2 biggest concepts that we deal with in this class are forces and moments. Okay? So forces will be the focus of exam 1, and moments will be the focus of exam 2. The definition of a moment is the product of forces and distance. So you're going to have some forces on exam 2. It's unavoidable. That doesn't mean that that's the focus of that exam. It's just that's what's going to happen. I've been teaching for quite a long time, and one of the things that I did when I started to develop my teaching philosophy is I drew up a list of all the crap that used to annoy me when I was a student that professors would do. I'd say, I'm not going to do that. That's pretty much my teaching philosophy in a nutshell. And one of the things that used to annoy the hell out of me is when a professor would give an exam that would take 4 hours to do and say, you have 50 minutes, go. I don't like doing that. I've never liked that, and I do my best to ensure that. One of the things that I do is I use a rule of 3. And what my rule of 3 means is I build an exam, and the idea is that if I can do it in 20 minutes, you can do it in 60. Okay? And that's what I do. I actually make the exam, and I turn on a timer, and I do it. Okay? And if I can do it in however much time I give you divided by 3, then you shouldn't have any time issues. I've been doing this for a long time. I've never really had a significant problem with time crunches on exams. And if it takes me longer to do it, I'll cut material out so that you aren't incapacitated. That's something I've done for years. It's always worked out with me. So that's my pledge I make to you right now. Okay. Any questions? I want to pull up the syllabus and pull up Blackboard, and then we'll talk about why the heck you're even in here. So, any questions? Okay.
Yeah, Professor,
yes, sir.
What's the format of the exams? Is it like typically like written response questions type?
That's a great question. So the question was, what's the format of the exam? And here's my answer. So the exams will tend to have 2 types of problems. There will be a set of conceptual problems where there will be short answer questions, maybe like 4 to 5 of them. And when I say short answers, I mean, this is something, it's good to say this on day 1. When I say short answers, I mean short answers. I have had students write me Shakespearean sonnets for a problem that's worth 3 points. Don't do that, you know what I mean? So there will be about 4 or 5 problems that are short answer, and then 3 computational problems. 2 to 3, maybe 4, like somewhere in that range. Again, that was the model I used even last year when we did it online. Never really seemed to be an issue with time crunch. In fact, if there was ever an issue with the exams, it was maybe technology based, like the internet went out, and we're all here. You know what I mean? So if somebody in here is working and they went, oh, the exam petered out, I can go in and reset it. You can start it back. So yeah, I think a lot of those issues will be avoided. But that's a fair question. Any other questions? Yes, sir.
Do you do variables and numbers, or I know Dr. Beanie does variables only.
So I'm not a system parameters guy. I'll go ahead and tell you that. I'm not that guy. I don't do that. I'm an engineer. Now, let me be clear. Okay, let me be clear about something. All right. How many of you have ever? I'll give you an example. How many of you have ever been to maybe like a Hispanic restaurant or a Thai restaurant, and you look at the menu and there's the items that have the little chili pepper next to it? What does that mean? It means They're spicy, right? Well, here's the thing. I think that what we ought to do for you is we ought to pull your curriculum sheets, and any course that has a letter C next to it means there's some calculus in it. And this class has one of those little chili peppers next to it. There is calculus in this class. I'm not going to avoid that. I'm not going to deny it. It's necessary for some of the things that we do, particularly the computation of centroids, particularly some of the centroid of a body, centroid of a curve. We need that stuff. Okay, it's unavoidable. But I'm a bridge engineer, right? I haven't designed many bridges that are X long. I'm serious, you know. I'm a numbers guy. I am, you know. To me, it makes it easier to process and easier to understand. Now, I'm not completely opposed to formulas and expressions. There are some cases in the class where on a homework assignment, I may have you derive something because I want you to understand where the formula came from. So I'll give you an example. When we do centroids, you will use sort of a library of formulas for various shapes to compute the centroid of a plane wing or a dam or a bridge beam or so on and so forth. And in order to do that, you need the centroid of a rectangle, the centroid of a triangle, the centroid of a circle or something. And I might have you derive those so that you understand where those came from. But to be clear, 2 meters, 4 feet. Yeah.
Thank you.
Calculators are fine. Absolutely fine. And I'll tell you this, I don't care what calculator you use as long as it doesn't have a Wi-Fi connection. I don't care about that. So your cell phone, no. Any other calculator, yes. I don't have a problem with that. I would recommend that you use something like a TI-36 or a Casio FX115 because it's approved for the FE exam, which every single student in this room should be considering that. I don't care what your major is. But I'm not that. I don't do that. I know what you're asking, and don't worry. Any other questions? And it's a fair question, by the way. Okay. Let me show you the syllabus. So here's the syllabus for the class. Let me sort of make that a little bigger. There's nothing in here that isn't on the presentation everything that was on the presentation is on here. I should say it that way. And there's obviously more stuff that's on the syllabus, but I think I highlighted the critical stuff in the presentation. I do want to show you some stuff with our schedule because I want you to be aware of some things. So let me show you, let's just pull exam 2 as an example. So our exam dates are pretty set in stone. This is a pretty structured class. Let me give you the exam, just as exam 2 as an example. So exam 2 is on Wednesday, October 20th. And I'll tell you what we cover. We cover rigid body systems and rigid body equilibrium, which is basically moments and applying moments. On Monday, October 18th, we have exam 2 review. And so let me explain how exam 2 review will go. I will come in, and for about 5 to 10 minutes, I will tell you what's going to be on the exam, what's covered on the exam. I'm not going to tell you the answer to problem 1, but I'm going to tell you what to expect, what topics will be covered, etc. What you're going to do is and I'm only going to do that for about 5 or 10 minutes. What you're going to do is come in prepared, ready for questions, and you can ask whatever you want, okay? You want to ask me about some concepts that you didn't understand? Bring it to the floor. You want me to go through a homework solution that didn't make sense? Let me know. You want to do a problem? We can do that too. And we'll use consensus for the class because I don't want to spend 30 minutes of our exam review on one problem. You know what I mean? If you ask a question with a 50 out of those people, I want to make sure their questions are answered too. But it is your forum to ask whatever you want. We won't have homework due the next day. I don't have homework due on when we have exams coming up. All you do is get ready for the exam. Okay. Let's see. A couple other things. On Friday, September 17th, and I don't know if any of you have had engineering courses already today, but that Friday you shouldn't have any engineering classes. The college is having a retreat, so just about all of your engineering courses should be online or makeup or something like that. So on Friday, September 17th, I'll have an online lecture for you to review. Basically, I'll record it in advance. You all can watch it on your own time. But that's the only day that we're going to do that. The other thing I will throw out is my goal for exam 3 is to do, so for the week before Thanksgiving break, we will do our exam review on Monday, we'll do our exam on Wednesday, and assuming we're making good progress in terms of our schedule and keeping up with our topics, we'll call it for Friday. So you get the Friday before Thanksgiving off. Unless you want to come to class. Does anybody want to come to class the Friday before break? I'm waiting for that one person to raise their hand, and so that everybody in the class can stare at them and go, really? No. I'm kidding. All right, let me pull up the Blackboard page, and then I'll pause it again for questions. So this is the Blackboard page for the class. It's going to fill up with stuff as the semester progresses, but you can see a copy of the syllabus. I thought it'd make more sense to distribute that this way than it would be to try and hand out 60 paper copies of something if it's here anyways. There is a link to the YouTube playlist for the class. Right now it's empty. There's nothing there because we're recording that lecture today. Again, the audio might be a little weird for today, but from here on out, I think it'll be fine. What you see are two folders. One says lecture notes and supplements. If I open that lecture notes and supplements folder, you will see the lecture notes for today already there. All the slides and whatnot. The PowerPoint slides are there. Okay? If you go back to older homework, so in lecture notes and supplements, as we go through the semester, you'll see all the slides will be there. So all of the lecture notes in PDF format. If you go into older homework assignments and solutions, it's empty because as we assign homework and as you submit it and as it's graded, I will post the homeworks and the solutions there. So you'll have all of that for review. And if you go into my grades on the left, let me find my mouse pointer. You'll see that the grade structure has already been figured out. As grades come in, that'll get updated regularly. So my goal for you is that if you want to know what your grade is, look, and that's your grade. I don't want you to go, well, wait, there's all this stuff outstanding. Now, to be clear, there's 60 people in the room, so I will do my best to keep up with that. I'm supposed to have a couple TAs for the class, but it might take a while for them to get hired and get grading, so I will keep up with it as expeditiously as possible. The first homework assignment should sort of grade on their own, and then after that it'll be business as usual. Okay, I'm going to stop for a sec and see if anybody has any questions before I get into why the heck you all are even in this class. Any questions? Yes, sir.
Do you ever upload like previous semester's exams to Blackboard for us to use as study resources?
That's a good question. So for this course, I'd say no because I've only taught it once. And the other thing is I don't think it would be particularly helpful because I think the exam's probably going to be a lot different than last year just because. I might consider doing that if I have a library of exams to go off of, but usually I didn't teach this class, but there's nothing usual about academia these past couple years. So, but this might end up being my class for a while. I love teaching it, even though it was a weird way of doing it. So that might be something I consider in the future. One thing I will tell you, I have a YouTube channel. My recordings from last year are there, so I don't have any problem. Anybody can watch those. So, any other questions? All right, let's talk about why the heck you're in here. Now, I got civil engineers, I got mechanical engineers, I got biomedical engineers in this room, all sorts of different engineers. And I could start reading out some textbook or Encyclopedia Britannica or Wikipedia definition as to what engineering is, okay? But if you want a simple, concise answer, we solve problems. That's what we do, right? We solve real-world problems. Now, we solve particular types of problems, and we use particular tools to do that, but that's what engineers do. Now, what are those tools? Well, we use math, science, physics, chemistry, etc. to in particular fields. I mean, what is the difference between a civil engineer or a mechanical engineer or a biomedical? It's just different problems, right? That's all it is. Now, we do use some common tools. One of the most common tools that we use in engineering is physics, okay? What is physics? What is it? I mean, and I'm not, it's a rhetorical question. I'm not asking anybody to raise their hand and start giving me a definition, because I could, if I did that, if everybody gave me their definition, I'd get 61 different definitions, and they'd probably all be some degree of correct. You know, they'd all probably have some truth to them. I'll give you my short and sweet definition. Physics is the study of matter, energy, and the interaction between them. That's physics, okay? Now, physics is a really big field, and there's a lot of various sub-disciplines inside that field. It's a lot like engineering. Engineering is a big field, and within that there are civil engineers, mechanical engineers, electrical engineers, etc. Well, physics is a big field too. Physics, you know, you have folks that focus on optics, focus on particle physics, electricity and magnetism, condensed matter, you name it, okay? One of the most popular branches, or the most useful branches of physics, is mechanics, okay? So, what's mechanics? Mechanics is the branch of physics that deals with systems or bodies or particles under the action of forces, okay? So that's what mechanics is all about, is taking forces, applying them to bodies, and seeing what happens, looking at the response. Now, we're going to build off some basic concepts in physics, but really what we focus on in here is mechanics, and particularly a specific branch of mechanics. Some folks ask, do you need physics to be able to negotiate this class? No, I don't think you do. Physics, and maybe I'm specifically talking about Physics 211 at Marshall, but you talk about a big variety of stuff. I mean, we're talking about origin of the universe stuff, and thermo, and optics, and magnetism, and all sorts of stuff. And we're only taking like 1 week in Physics 211 and making it our whole focus, because it's what matters to us in here. Really what matters in here, in terms of negotiating the class, is your math skills. If you got, I think the math in here is much more important. Your ability to do algebra and trig is probably most critical. Now, let's talk about mechanics. Okay, let's categorize mechanics a little bit. So, when we look at mechanics, we need to look at two areas, two categories. I said that mechanics was the study of looking at systems, you know, bodies, particles, what have you, and looking at forces being applied to those bodies. So the first thing we need to look at is the media at which we're studying. And so what I mean by that is, are we looking at rigid bodies, bodies that are assumed not to deform? Are we looking at deformable bodies, bodies that we do consider that deformation? And maybe we're not looking at solids at all. Maybe we're looking at fluids. Maybe we're looking at liquids or gases. The other thing we need to look at is the condition of the problem at hand. And when we look at mechanics, there are two conditions that we're interested in: statics and dynamics. So what is statics? Statics is looking at bodies that are at rest, or technically bodies that aren't accelerating. So bodies that are at rest or at a constant velocity, whereas dynamics is dealing with bodies that accelerate. So if you want an idea of what we're talking about in here, this is what we're dealing with. This is a course dedicated to statics. This is part of a two-part course. This is Engineering 213. The next course is Engineering 214. That focuses on engineering mechanics. Part 1 being statics, part 2 being dynamics. Now, as for the media that we consider, what we're going to be focusing on in here is rigid body statics. And so, let me sort of break that down for you so that you understand. Okay. Everything in this world, everything, every system, when you apply a load to it, it deforms. Nothing in this world is perfectly rigid. I'm standing on this stage. I'm telling you it is deforming under the load that I'm applying to it right now. But how much is it actually deflecting? Very little, right? It's a pretty sturdy floor, right? It's not really sagging, like a trampoline, right? So even though this is technically a deformable body, from an analysis standpoint, I can assume that body to be rigid because rigid body mechanics are a little easier to deal with. I can use that assumption of rigid body mechanics in order to determine the forces and the response of that system, okay? And that's really important for what we do as engineers, okay? So let's take the room that we're in right now. There is a lot of force being applied to the floor system in this room right now, okay? I mean, how many students we have here? 60 students? Let's say the average student, make up a number, how much they weigh, X, So 60 times X load is being applied to that floor system. We need to understand how that floor system is going to respond to that load. Because I don't know about y'all, but I don't think you all want to stand in a building that's collapsing or a floor system that's collapsing, right? We need to understand that response. Assuming rigid body behavior is sort of the first step, okay? That's what you do in Engineering 213. What you do in Engineering 216 is consider those deformations, those resulting deformations. Because now, this is where it starts to get really fun, because you start to say, okay, let's say I have a steel beam. I put load on it. I use the principles of statics to determine the internal forces and the response. Then I use strength and materials to see, well, how much is that beam deforming? How much stress is being applied to it? And if it's too much, I can then size or design that beam to ensure that it's safe. And that's engineering. That's kind of what we're doing here. And it doesn't matter if we're talking about a bridge beam. It doesn't matter if we're talking about a gear in an engine. It doesn't matter if we're talking about a pacemaker, right? For you biomedical engineers. It doesn't matter. The concepts are the same. Now, like I said, in this course and in the following course, we're going to be dealing with rigid body behavior. Some of your later courses, you'll look at deformable behavior. So in 216, you'll consider deformable behavior of static bodies. You might talk a little bit about deformation of dynamic systems in 214, but really dynamics of deformable bodies is a specific area of mechanics. You're talking about vibrations. Okay? Vibrations is a little bit of an advanced topic. You might talk a little bit about it in 214, but really that's kind of a grad school thing. Or maybe an upper level senior thing. I know when I was in college, I didn't learn really about vibrations until graduate school. For mechanical engineers, I think it's pretty obvious why you want to understand vibrations, and probably even for you biomedicals too. For the civils, you might go, why would I care about that? Who cares about structures vibrating? Earthquakes. Because that's what an earthquake does. You're accelerating a building. So that's kind of what that is. There's a whole course, Engineering 318, dedicated to fluid mechanics, fluid statics, fluid dynamics. But I kind of wanted you to understand what this is all about. I am providing you, well, I'm not providing, I'm just explaining. You all are doing work. But we're providing you the framework for how you're going to go about designing in the future. You know, it's kind of funny. How many of you have a relative, an older sibling, a friend, anybody who practices as an engineer? I'm just curious. Now, I always found this is an interesting question, or interesting two questions. Ask them these two questions, and do it in this order. Question one, how important is statics to engineering, or something like that? What was the most important class that you took, something like that? And a lot of them will say statics is incredibly important. Some of them might say statics is the most important class that they ever took. Some of them might say that statics was the weed out class. I don't treat it like that. I've never been that guy. I think everybody in here has the tools to succeed. I just want to see if I can help you do that. But then the second question, how many statics problems do you do a day? Oh, none. They might say none, even though that's actually not true. I don't know that I'm breaking out vector notation when I'm designing a bridge, but if I don't adhere to those principles of statics, that bridge is going in the river, okay? So, and it's true of bridges, It's true of mechanical design. It's true of biomedical design. If your design doesn't adhere to these basic principles, then you've got problems. And this is where it starts. I know you had a year of college before this, and you took CAD and maybe some intro chemistry classes and math classes. I'm going to tell you that this is where engineering starts in here, okay? And I don't mean to say those classes weren't important, although they were very important. But you're going to start to see that as we progress through this semester, that this is where it begins, right? Once you understand how bodies respond to, an application of forces, you can then start to think, well, wait a minute, now how strong does that system need to be to withstand those loads? And that's design. That's engineering. That's what you're here for. All right. Questions? Anybody have any questions about what we're doing? Again, no homework due today, just on the logistics side. This is all about relax. I promise I'm not a weed out professor or anything. No, seriously, any questions? All right, so real quick, just on logistics. So on Wednesday, we are going to actually begin some work. I'll go ahead and tell you that it's probably not a bad idea to start bringing a calculator to class. Make sure you bring a notebook. Make sure you bring a pen, because we're going to be doing problems together in class, okay? Your textbook in class you can bring it. I'm not one of those guys who's going to say, okay, read paragraph 3 on page 246. I don't do that, Like, we're grown-ups. So, just come to class ready. Come to class ready to ask questions. If you're asking questions, you're engaged, and I'm happy. So don't ever feel like you're interrupting me. I think we're going to have a lot of fun in here. That's all I got, everybody. See you on Wednesday.